Well, hello everyone. I had been really looking forward to being the lead-off speaker for the first live event, but I guess that's going to be a future opportunity for me. So we are, as we've mentioned, we're changing things up a little bit today. We've got a great poster session set up, and please do drop on by. But in the meantime, I'm going to be talking to you about the OGS's newest 3D sediment mapping project, and that's happening in the Guelph area. I'd like to acknowledge, let's see if I can get, oh, Kayla, your computer's not playing along.
Oh, that's because Rob is sharing his screen.
Oh, okay, we need the next slide. There we go. So I would like to start by acknowledging my co-author, the latest member of the quaternary mapping team, that's Grant Hagedorn. He's seen on the right-hand side, as well as my student Adam Kelly from this past summer. And you can see it was considerably nicer in Guelph in the summer. Next slide, please. So in the next 15 or so minutes, we're going to be looking at the where and the why of the Guelph project. We're going to spend quite a bit of time looking at surface deposits, and then at the end, we'll be digging just a little bit deeper. Next slide. Now, 3D mapping at the Ontario Geological Survey began in about 2002, and that was with the Waterloo Region project from Andy Bites. Since then, we've expanded to 7 ongoing and completed projects, both above and below the Niagara Escarpment. And the whole goal behind these is to contribute to an improved understanding of regional groundwater systems. And these projects are used for land use planning, source water protection, modeling, and geotechnical projects. We have a whole range of different products that come out of each project. We usually start off with geophysical data sets, and we move on to drilling. From there, we release analytical results. We release borehole logs. We have the actual models themselves, of course, detailed reports. So there's a whole host of different products that come out throughout the life cycle of each project. Next slide. And as you can see, there was a considerable hole in our coverage above the escarpment, and that is going to be filled by our next project, the Guelph area, and that's what I'll be talking to you about today. Next slide. So to zoom right into the Guelph 3D project area, it's about 1,400 square kilometers, and you can see it's quite a built-up area. We take in portions of Waterloo Region, Wellington County, the RM of Halton, the city of Hamilton, and of course the city of Guelph. Our other cities are Cambridge, Kitchener, and Waterloo. And that wobbly blue line that runs through the center of the screen, that's Highway 401. So no doubts that we are in a built-up area. And this, of course, creates many competing demands from industry, development for residential. We have market gardening, we have agriculture, and a whole range of other demands on our lands. Next slide, please. So to explore the theme of competing demands just a little bit further, we can see that there's large quarries, and these are shown in pink along the right-hand side, set up along the Niagara Escarpment, and that's indicated by the dashed line. Closer to the 401 corridor, where the sediments become a little bit thicker in the western portion of the area, we have numerous gravel pits. At the other end of the spectrum, there are areas of natural scientific interest, earth sciences and life sciences. We have parks, and although not shown on this map, there are numerous conservation areas and forest tracts. We also have the green belt, which is shown in gray, which is a tiny bit bizarre, but there we have it. Next slide, please. So there are also 4 different conservation authorities in this area. We have the Grand River, which encompass most of the central and western portion of the area. We have Credit Valley, Halton, and Hamilton as well. Now you can see that there's something interesting going on the eastern to central portion of the area where we have the big drainage divides. And I'm going to give you a bit of a preview. That's the area of the Paris-Galt Moraine. Now this is a very important area. We can see we've got all kinds of streams. It's their headwaters. And looking at the colors there, this is an area where we have cold water streams. Further to the west, there are more warm water. So this area is really important in terms of supporting base flow and fisheries. Next slide, please. So one of the goals of this project is to develop new 1 to 20,000 scale superficial maps. And there's a reason why we're going to be investing in this. It's not something we always do for our projects, but we do where warranted. And if we take a look at the tools that used to be available, the provincial DEM, you can see that it's pretty hard to pick out landforms. As time has moved forward, we've improved our DEM's swoop coverage beginning in about 2010 and more recently in 2015 for this area. We can start to pick out more and more landforms. And then finally, we have LiDAR, which is just absolute magic if we're into that kind of thing. So the view on the right shows what we can see now, all kinds of ridges, little eskers, and you can even see individual housing plots in that particular screen capture. So older maps weren't bad, they just were made with different tools, and we have the ability to improve things now. Next slide, please. Today we're going to be looking at 4 focus areas, starting in the northwest and moving to the southeast. And this is just going to give a flavor of the types of things that we can see and why these might be important to us when we're thinking about both glacial history as well as water resources. Next slide, please. So starting off in an area that shows considerable surface orientation. So even if you don't know what we're looking at, we definitely get the idea that there's movement and textural changes between the northwest and the southeast. If you can pop up the next slide. So these are drumlins and megascale glacial lineations, which is always fun to say. And these give us an idea of what direction glaciers have been moving. These are important features. They are composed out of tills, usually fairly compact, which is nice if you happen to need a confining layer or something to protect your underlying aquifer systems. I find them incredibly interesting in this area because we can see we've got nice short plump drumlins indicated by the dark green arrows, and those gradually transition to more composite drumlins, and then the lineations, which are the long, narrow, and low landforms that you really don't notice when you're driving through them. Those are indicated by the light green arrows. Next slide. Also in this area, we have a series of eskers, so small gravel deposits, and also much larger meltwater channels and a series of different terraces. And these are important because they are sand and gravel, which means for some people, they are going to be an important source of aggregate, but there are also areas where there's been incision through that upper till surface. So right away, we have windows into the underlying deposits. Next slide. Now, moving to the Paris and Guelph Moraine area, we can see there's quite a different set of landforms and just appearance to things going on. The most apparent is just to the right-hand side of that dashed line, and that's the hummocky terrain that the Paris and Guelph Moraine is so famous for. Next slide. There we go. So we've got a picture of what this looks like. The one at the top is some of those large hummocky areas, and these are really important because they help to control flooding, and they also promote very slow recharge. At the bottom area, we see what some of the lakes look like within this moraine system. Next slide. There are also a series of ice-walled lakes, and these are really interesting. It gives you lake deposits, so silt and clay, sitting fairly high on the landscape. You might also notice, just to the right-hand side of that blue dot area, that we can see individual landforms within those hummocks, and those are a series of ridges. Next slide. Grant and Adam spent quite a bit of time on the Auger this summer, and this particular site, there was about 3.5 meters. At the bottom, we had sands and gravels of the ice contact deposits, but then there was about 1 meter or so of rhythmically bedded silt clay and a bit of sand. So clearly this particular area isn't going to be a source of much recharge. There was then considerable deposits of peat on the top. And since it was such a dry summer, we're able to get out onto some of these former lake bottoms and do a little bit of work. Right, next slide. We can also see that there's numerous ice contact fans. Those are picked out in the orange dashes and larger fan systems. We have shown by the wiggly blue lines, those are meltwater channels, which are feeding some of those fans. The fans are really important because they are quite sandy. We also have eskers, and those are shown by the yellow arrows. So we get to see a real snapshot view of the subglacial plumbing system. And the much larger channels that characterize the city of Guelph, those are shown in purple. And we have several terraces. Some of these channels are bedrock floored, others are filled with quite coarse gravels. So an important area to get a handle on in terms of resource management. We also have areas where there are erosional remnants. So drumlins, those are picked out by the blue dash line and the green arrows. And these are going to be contrasting in terms of surface permeability. They are quite compact dimicton, so really quite different from the surrounding sands and gravels. Next slide, please. Now and then, the Public Works Department, they give us a gift in the form of ditches. And one day we were driving along and discovered about a 400-meter long section, which was quite wonderful. Well, easier than digging anyway. This particular section transitioned from the coarse gravel of an esker at the south and gradually moved off into the dimictons you might expect in a glacial environment. And then we started to see draping silts and clays on the top. And that was in that really flat looking area that's circled in blue at the bottom right-hand side of your screen. So you get to build up a bit of a picture of what's happening in the subsurface as well. Next slide, please. Okay, moving into the Moffat Moraine area, the first thing that we notice is that we've gone from the quite apparent hummocks to a series of fairly vertical looking ridges, at least on this particular view. We can also see that the drumlins have changed from that first area we looked at in the northwest. Here they're much smaller. They've been somewhat overprinted, and we can see that instead of being really even and regular in terms of orientation, we're starting to see a bit of a curve pattern showing up. Now, if we focus on those ridges, they're quite interesting. Some of them are moraine ridges of the Moffat Moraine, and these are quite curvilinear. Some of these have been picked out in green, and we need to contrast those with bedrock ridges, which I picked out in pink. And it was a big part of the summer's task to come up with a way of distinguishing between them. Obviously, you can't go and check absolutely everything. So what we found out was that the moraine ridges are less regular, they're more curvilinear, whereas the bedrock ridges tended to have smears of sediment on the down ice side. It looks quite obvious once you get your eye in, but it took a little bit to develop those eyes. Next slide, please. So there we go. It was quite hard work figuring out which was which, and that was Adam. He was really pleased. I was walking up somebody's driveway. We found quite clear evidence of the bedrock. Sometimes we looked at developing other cues. If it's a graveyard, well, it's probably going to be a moraine, not a bedrock ridge. Same with houses with basements. So you take what you can get sometimes when you're doing field work. Next slide, please. We can also see all the other elements you'd expect in an ice marginal environment. We have fans, once again picked out in orange, meltwater channels in blue, and eskers depicted in the yellow arrows. Next slide. So taking a quick look at this fan system, we expected to see a fairly simple record, but it turned out that there were a few surprises. This was a roughly 1,400 meter long area. We were able to auger down, I say we, Grant and Adam were able to auger down about 5 meters. I had nothing to do with it. I was just along for the ride. what they discovered is that it wasn't just sand and peat in this area. There were numerous holes where we found some diamicton. So it turns out that there was a bit of a buried moraine in that area that had been bisected by meltwater channels and then overlaid with sand deposits. These found upwards into clay, unfortunately quite thin, so not much of a confining layer, and then peat on the top, as you might expect. Next slide, please. So on to our final focus area, and what we can see here is that those ridges are starting to change. Once again, we have the moraine ridges in the far west, and those are picked out with some of the green curvilinear lines. We also have some of the more distinct bedrock ridges, and a few of those are shown in the pink. Then as we continue eastward, the bedrock starts to get more of a rhinoceros skin pattern on it. And can I have the next slide, please? And there we go. So the bedrock has changed. It is absolutely unmistakable. It's fractured, a lot of karst here. And if you want to know a lot about bedrock, then we need to talk to Frank Brunton, another one of our great OGS staff members. So look to his work for that. Next slide, thank you. We also see changes in our drumlins, and the one that is shown by the orange arrow here is clearly overprinted. It was deposited and then reworked by later glacial events. We can see that there's a bit of a smearing effect. We also have shorelines on this particular one, and that's shown by the orange dots. So we get a real sense of how the landscape has changed over time. Next slide, please. Not wanting to be outdone, we also augured into this area. And here we go. Next slide, please. There's some very important trends. In this area, there were some auger places where we had diamicton overlying the bedrock. We didn't find these in other areas, but it was still definitely dominated by lacustrine and glacial lacustrine deposits, so fine sands moving up into silt and clay, and once again, peat. You're probably wondering why on earth there's so much peat in southern Ontario. Well, it's pretty darn difficult to auger into dried out diamicton and clays. So of course we head into the damp wetlands, as it's just a place where we can work more effectively. So that's why it looks like there's a lot of peat there. Next slide. We also found evidence of a lot of glaciofluvial deposits. So once again, a handy ditch shows us some great outwash, so nice and gravelly and cobbly. And we also found some buried fan deposits, so coarse sands, and these do transition upwards into silt and clays. And depending on the resolution on your screen, you might notice that there's some pink deposits in there. Well, they weren't pink. That's actually marl. So that's evidence of shallow water organisms, and it really records that transition from lake clays up into the peats. So we have a whole host of different sediments that aren't evident at surface. We're going to have sands, we have some silts and clays, and of course those peats as we move through these different areas. Next slide, please. So why so much about landforms? Well, landforms translate into sediments and gives you an idea of what the permeability might be right in that exact location. But if we can put these landforms together into a broader land system, we're going to start to be able to predict trends in sediments and therefore identify more potential recharge areas. But it's still only half the story on why we're so focused on this type of thing. And that's because when you add in knowledge of Quaternary history, you start to build up a picture of stratigraphy, and from there, real recharge and aquifers. So the main event. Next slide, please. Fortunately, we have a wonderful composite section that has been developed from the surrounding project areas. This particular section goes through the Brantford, Waterloo, and Niagara regions. So in the Guelph area, we'd expect to see sediments similar to the ones that are circled in black. Next slide, please. All right, so we have Catfish Creek Till. We might expect to find some of that with older deposits below, and that's shown with the green arrow. We have the Waterloo Moraine shown by the orange arrow, and we also have the thick sand and gravels of outwash deposits, and those are shown in beige. Next slide, please. So how does that translate into the reality of the Guelph area? Well, these white arrows, once again, are just highlighting some of these drumlins and their skinny cousins. And we can see right away that we do have the really regular oriented deposits up in that northwest, and things are quite different in the southeast. And we might think about why that's happening. Next slide, please. And there we go, the Paris and Galt Moraine slapped in the middle. For those in the know, the Paris and Galt Moraine is the westward extent of what we're going to call, for convenience, Wentworth Till. So we might expect to see older deposits, thicker ice to the west, and younger deposits, thinner ice, topographically controlled to the east. And that's probably digging just a little bit too deep into glacial processes. So we'll have the next slide, please. There we go. So we have, as we might expect, Port Stanley Till in the west, Wentworth Till, and then much more clay-rich Halton Till below the escarpment. We also have thick areas of those outwash gravels shown in boring beige and the Waterloo Moraine in orange. So we're going to start to build up the picture of the stratigraphy and relate it to those glacial processes and changes over time. Next slide, please. So next steps in the Guelph area. Well, we are in the works of planning our geophysical program, a ground gravity survey. From there, we will be out on the drill rigs trying to get an idea of what's happening in the deeper subsurface, and of course, continuing our mapping operations. Next slide, please. So with that, thank you very much.